Okay, so welcome back, and I hope everyone is okay. So, in today's lesson, we'll actually continue from where we ended. We'll do extraction of iron. Previously, we did extraction of zinc, and we looked at some ores of zinc and how it's extracted from its ore. Then with this one, we'll focus on iron and how it's actually extracted. So first thing you're supposed to know are the ores of iron. The ores of iron. One, we have what we call hematite. So this is one of the ores of iron. So the chemical name for that one, the chemical name for hematite is actually iron 3 chloride, iron 3 oxide. That's the chemical name. So hematite with that chemical name. Then the other ore of iron is magnetite. So magnetite is actually triiron tetraoxide. Triiron tetraoxide. Then the other ore of iron is siderite. Siderite, which is iron 2 carbonate. So these are the three ores of iron. Hematite, which is iron 3 oxide. Magnetite, which is triiron tetraoxide. Then siderite, which is iron 2 carbonate. So the chief ore of iron is actually this one, which is the chief ore, hematite. So if you were asked to state the chief ore of iron, it is hematite. So from these compounds, that's why they get iron and extract iron. So extracting, as we said last time, removing that metal from its compound. So we are actually removing iron from its compounds. So iron carbonate, removing iron from its carbonate, removing iron from its oxide. So the method by which iron is extracted is by reduction. Iron is extracted by reduction in a blast furnace. So this is actually a blast furnace. And in this blast furnace, there are three substances that are put there in a blast furnace. We have one, the first substance they put is actually coke. The second one, they get the iron ore. Then the other one is limestone. So these substances, they are actually mixed, and the substance they form is what we actually call as the charge. So they get iron, they mix it with the limestone, they'll also mix it with the iron ore. So all this combination actually forms what we refer to as the charge. So these three substances, they'll be put in the blast furnace. And over here, we have hot air. Hot air entering the blast furnace. So we need to know, when these three substances are put in the blast furnace, what actually happens? What are some of the reactions that take place? So first thing, what will happen is that with the coke, we'll start with what will happen to coke after it is put in the blast furnace. So coke is actually pure carbon. That is carbon. So you'll find that immediately it is put in the blast furnace, there is hot air entering. So you find that hot air with oxygen, that coke, which is pure carbon, it will react with the oxygen and produce carbon dioxide. It will react with the oxygen and produce carbon dioxide. This carbon dioxide, it will rise. It will rise. So after rising, it will react with more coke, because here we are actually putting more coke. They are putting coke inside the blast furnace. So immediately the coke reacts with oxygen and produce carbon dioxide. The carbon dioxide will rise and react with the coke they are putting. So coke, the carbon dioxide which is rising, it will react with more coke and produce what we refer to as carbon monoxide. So these are some of the reactions that take place. This is one of them. So when coke is put in the blast furnace, this reaction will take place. Carbon, which is pure carbon, coke, it will react with oxygen and produce carbon dioxide. Carbon dioxide will rise. It will rise and react with more coke in order to produce carbon monoxide. So in this reaction, in this extraction of iron, since we are saying that iron is extracted by reduction, so meaning there should be a substance that will be a reducing agent that will be reducing iron, removing the oxygen from the iron. So here, this same reaction, we are actually producing the reducing agent. So here, the reducing agent for this reduction of iron from its ore is carbon monoxide. So the carbon monoxide produced, this will be the reducing agent that will remove oxygen from iron. So under this one, since we are done, this is actually the reaction when coke is put in the blast furnace. This is the reaction that occurs. Now let's look at the other one. So here we have, let's focus, because we said that there are three substances put. There is coke, there is the iron ore, there is also limestone, which is calcium carbonate. So when calcium carbonate is put in the blast furnace, what actually happens? So remember again, if you check here, there is the hot air entering the blast furnace. So immediately calcium carbonate is put in the blast furnace. Immediately calcium carbonate enters here. Immediately it meets with hot air, a high temperature. This calcium carbonate will decompose. It will undergo decomposition where it will break down and produce calcium oxide and carbon dioxide. So it actually produces this calcium oxide and the carbon dioxide. So this one, what it actually does is that it reacts with the impurity, which is with the iron. So you find that this calcium oxide that is produced, it will just help to remove the impurity that is with the iron. So it just removes the impurity. So calcium, the purpose of calcium carbonate in this furnace, it acts as a flux which produces calcium oxide that reacts with the impurity on the iron. So there is another reaction. So this is actually the reaction when calcium carbonate, which is limestone, when it is put in the blast furnace. That's the reaction that takes place there. So the reaction now, that's for calcium carbonate. Now the reaction with the calcium oxide and the impurity, because there with iron there will be some impurities such as the silicon. So you find that dust, all those things. So you find that if calcium reacts with silicon, the dust which iron is found with, if it reacts with that one, it will actually produce calcium silicate. So that calcium silicate, it plays a big role in the furnace, which we'll actually look at. So we'll mention it later. So let's focus on the hematite now. If we put the iron ore, if we get this hematite, if we put it in the furnace, so if we get the iron ore and put it in the furnace, so we said that iron is extracted by reduction in the blast furnace, and the reducing agent there, it's carbon monoxide. So iron plus carbon monoxide will actually produce iron plus carbon dioxide. So the iron that is produced will actually be in liquid state, which trickles to the bottom of the furnace. It actually trickles to the bottom. It will come and settle down here to the bottom of the furnace. So it will actually be in molten state. It will not be in solid, it will be in molten state because of the high temperatures that are there in the furnace. So you find that this iron produced, it will have some impurities, the silicon, as we said, and what will help to remove those impurities? It is calcium oxide that is produced when calcium carbonate decomposes. So there, calcium oxide, after it reacts with the impurity, which is silicon, it will produce calcium silicate, which is the same molten slag, the same slag that is the same one that is actually used in making roads. So you find that after molten iron settles at the bottom here, after molten iron settles here, molten slag, the same calcium silicate, after it's produced, it will float on top of the molten iron. So here we have calcium silicate, the one that will actually settle on top of the molten iron. So molten iron, this calcium silicate, settling here on top of the molten iron, it will actually prevent this iron that has been produced from reacting back with the oxygen here. Because if this iron is left open, exposed to oxygen, it will react back and produce iron 3 oxide. So this one, it plays a bigger role. The impurity, this substance that is formed, the molten slag, it plays a bigger role by preventing molten iron that has been extracted from reacting back, from reacting with oxygen and producing calcium, iron 3 oxide. So according to the questions now, since we now have an overview of the whole thing there that takes place, so let's now begin to answer the questions that are there. So coke and materials X and Y are fed into the furnace. The same materials we stated, because there are 3 materials that are fed into the furnace. We have calcium carbonate, which is limestone. We have the hematite, which is the iron ore. We also have the coke. So name the materials X and Y. So on this one, we can actually say X, it can be hematite with the formula iron 3 oxide. And Y, we can say that is limestone. Limestone, which is calcium carbonate. So this question came, it's actually an exam question. So the next question said, what is the use of the waste gases? So with what we discussed, with what we have mentioned here, there is actually a gas being produced. So if we concentrate, if we check the reaction, the reduction of iron here, the oxide reacting with carbon monoxide, producing iron in molten state and the carbon dioxide. So this carbon dioxide, it will actually leave through this point. It will move up and leave through this point as a waste gas. It will actually move out as a waste gas. So we need to know the purpose of the same waste gas that will leave through this point, because the waste gas here, it's actually carbon dioxide. So carbon dioxide, the purpose of carbon dioxide, one is that this waste gas, carbon dioxide, it can be used by, if it is disposed into the atmosphere, it can be used by plants in photosynthesis. It can also be used in brewing and baking. It can also be used in making carbonated drinks. So it has a lot of uses, and again it can be used in fire extinguishers, because this gas, the waste gas, which is carbon dioxide, it doesn't support burning. So you find that it can be used for a lot. It has a lot of uses under this one. So on this one, we can just state one. Used in baking and brewing. Baking and brewing. So as we have said, it's not only in baking and brewing, it is also used in fire extinguishers, because this gas doesn't support burning. It is also used in making carbonated drinks, so as we have stated. So the next question is saying, what is the reducing agent in this extraction? So you can pause the video and try to answer it according to how we have what we have actually mentioned. So the reducing agent in this one is actually carbon monoxide. Carbon monoxide. So this is the reducing agent. Then the next question is saying, describe how the reducing agent is produced. So the reducing agent that is produced in this one, you have to explain how it is produced. So first thing, it is the coke itself. After they have put coke in the blast furnace, you find that it will react with the hot air that is entering the blast furnace. After reacting, because that hot air contains oxygen, so the coke will react with the oxygen in hot air and produce carbon dioxide. So that carbon dioxide, it will rise and meet with more coke. So it will react with more coke, that carbon dioxide, and produce carbon monoxide. That's how this reducing agent is produced. First thing, coke reacts with the oxygen in hot air and produce carbon dioxide. Carbon dioxide rises and reacts with more coke to produce the carbon monoxide. So that's the simple explanation you can give on this one. Then we have the next question, which is, what is the purpose of each of the following? So we have hot air. What is the purpose of hot air? So this one we can actually say, the purpose of hot air is to decompose calcium carbonate, which is limestone, to decompose calcium carbonate, because immediately calcium carbonate is exposed to a lot of heat, it will actually break down and produce calcium oxide and carbon dioxide. So for this one, the purpose of hot air is actually to decompose the calcium carbonate, or to oxidize the coke itself, because in hot air there is actually oxygen. So the purpose of that one, it can either be to decompose calcium carbonate or to make coke react with oxygen and produce carbon dioxide so that the reducing agent can be produced. So what is the purpose of each of the following again? Coke. What is the purpose of coke? This one, the purpose of this one is actually to produce the reducing agent, because without this one we can't produce the reducing agent, which is carbon monoxide in this reaction. Because from coke, that's what we are actually making up. That's what we are producing, the reducing agent, which is carbon monoxide. Then on this one, the last one, show the balanced equation in which iron is extracted from the ore. So the balance, so since iron is extracted by reduction in a blast furnace, so we'll get the hematite, which is iron 3 oxide, reacting with the carbon monoxide to produce, so there we'll have iron plus carbon dioxide. So here they are stated, so this is actually the chemical equation for the reduction of carbon, or for the reduction of iron 3 oxide. So now we need to balance the equation. So here, if we check, balancing the equation, we need to make sure that the number of atoms of each element, they are equal on both sides, the reactant side and the product side. So here we have 2 iron atoms, so we need to make sure that they are equal also on this side. So we'll try to put a 2 and see how we can balance it. Then if we check the number of oxygen atoms, we have 3 this side, but this side we have 2. So for us to balance that equation, we'll actually make sure that, because it's easy to balance it when you have even numbers. So we'll put a 2 here so that this side we can have, so this side will have the number of oxygen, we'll put 3. We'll put 3 so that if we add the number of oxygen atoms, it will actually give us 6. Then we'll go this side and balance the equation by putting a 3 here, so that if we multiply 2 and 3, it will actually give us 6. Then if we check the number of carbons we have 3, and this side 3. So this is actually a balanced equation for the extraction of iron. Okay, so that's it on extraction of iron, and this is actually the key thing on this one. You have to know the iron ores of iron, where we have hematite, which is the chief ore, the iron 3 oxide, then we have magnetite, which is the tri-iron tetraoxide, then we have siderite, which is iron 2 carbonate. So we need to know these, the chemical name and the common name of these iron ores. So, and also we need to know what is fed in the blast furnace, and iron is extracted by what process, which is reduction in a blast furnace. And we need to know also the reactions that take place in a blast furnace when iron is being extracted. So these are the things we are supposed to consider. Everything, what the purpose of coke in the blast furnace, the purpose of limestone in the blast furnace, and the reactions that occur, and how to write the chemical equations for those reactions. So these are the things you're supposed to follow, and make sure you master it, go through it regularly, so that you are able, you reduce the chances of forgetting these things. Okay, so that's all for today in chemistry. Nextly, we'll actually look at extraction of copper and the extraction of aluminium. Okay, so thank you very much. I hope you enjoyed. Have a good day.